and welcome to this lecture. So in the previous lecture we have implemented this enemy sum functionality of our Goombas. Now let's implement the coin function here. So go to this component and create this new Python file and name it as coin. So coin.py, we have coin.py. Let's implement or import some of this module, that would be pygame module, and import it as pg. And from basically this two dot is going back to this data directory. We'll just import setup from there. And next thing what you're gonna do is we'll import the constant. So just go again back to this directory, import me setup. So next thing what you're gonna do is we have now, okay, this is not setup, it should be constant. So import is C here. So next thing what you're gonna do is we'll just import, and this is it. So we have imported pygame and setup and constant. So let's define the class module here and just give a coin as in class name and sprite dot sprite. So now we can use this module or this function or this class in order to work with the images. So this coin basically founds coin in the box and a bricks. So this method or this class is basically for the Mario in order to find the coin in the boxes and in the bricks. So for that, let's firstly we have to do something, that is we'll just define a bunch of an attribute in this initializer, and that should be x and y. And let me say here that is score group. So if you just implement coin, there should be score attached to it, so this should be score group. So first thing what you're gonna do is we'll just take this sprite, and that would be, let's take this sprite sheet. So let me just make sprite sheet new variable, and what you're gonna do here is we'll just set up the GFX, that is loading this GFX, and just give here that is item dot object. So if you wonder what this item and underscore object is, you can check the resources and you can find you have something that is a coin there. So go ahead in object and you can find we have a bunch of a coin here, and we'll be using this type of coin. So if I just zoom it, and this type of coin and this type of coin will be used for our game. So let's get back into this coin.py, and we'll just set the frames for our current state, and obviously the frame index will be associated with each frame, and that should be frame index would be O here. And next thing is animation timer. So it should be animation timer should be O here. And the state, so current state here would be obviously the spinning state. That means just get this constant from here, and the current state here will be spinning state, because coin normally spins. So we say something that is just create this set of frames method now, and we'll just call it here. And next thing what we're gonna do here will be we'll just use some images, and that images should be the current frame. That means the image, let me say image, and this image should be initialized from this frames, and just get this key as frame index. So we have to make this rectangle out of this image. So just to get this self image first, and just call this method that is getRect in order to create the rectangle for the current object. So next thing we'll just set this center of an rect to be the x. So that would be like rect and center x would be our new variable here, and just make it as x, and just we should now displace this basically y, because the coin should be a nearly up position from that basically bricks, or maybe from any position. So the x and y here is basically position, and it should be quietly displaced. So let's make that bottom a quiet displacement, maybe 5 or a 10. So let me say self.rect.bottom now. So this bottom should be displaced. So if you just put y, it will just go inside or collide with our bricks. But if you just displace with something like 5, it will just appear as the top in that bricks. So next thing, we'll just set the gravity here, and gravity would be, let me say 1 here. So the self.y velocity, and this y velocity would be -15, and just get this initial height is should be self.rect.bottom, and this bottom should be now subtracted with 5. That is, we have that is initial displacement with -10 now. So if you see here now, the next thing what you're gonna do is we'll just work with this score group. So every time you basically gets that coin, there should be increment in this score, which will be handled by score group. So next thing what you're gonna do is, obviously we'll just get the image from this spreadsheet. So for that, we'll just define next function, that is get image function here. So get image will take the self, that is current object, x and y position for which the image should be extracted, and width and height obviously. So let's make this get image function. So in this get image, it basically gets the image frame from the sprite sheet, and for that I'll say image here, and just get that surface, call this surface. And now in this list we'll just pass, you can just also pass the tuple here. So I'll say the height and width that the surface has, and basically you just convert it. So after you call this, we'll just say make the rectangle out of that image, that is from, obviously we have something that is get rect function here, and after that we'll just split that image. So this split image will take first surface, which should be split. Obviously we have to split, that is sprite sheet here, and give the position would be O and O at the origin, and give now the dimension, that would be x and y the position, width and height is a dimension. Now we are done with this splitting the image. Now, as previous we have done in the case of enemy, we'll also set the color here. So from this set color keep method, we'll say that is the color should be set as black. So next thing what you're going to do is we'll just transform that image. Basically this is the smaller size, this image will be in the smaller size, because in this sprite, in this image object, we have very smaller image. So let's transform it with the constant size multiplier. So from that we'll just call this transform and scale method, and just give the surface, which should be scale, obviously the image should be scale, and the height and width. So we'll just say that is a rect width here, that is a rect width should be now multiplied by the constant size multiplier. And next thing what you can do is we'll say that is rect dot height, and this height should be again multiplied with this size multiplier. So this size multiplier will be in float, and we'll just typecast it to integer again here, and you just put it out integer here. So now we have just scaled image. Next thing what you're gonna do is just return that image from this get image. So now it's time to just make this set of frame method. So let's make that set of frame method. That would be just defining this setup, and that should be underscore here and frames, and just give the current object here, and this basically creates the frame list. So let's create that. So first we have these frames, and just append that in that frame with the images, and that should be from the getImage function, just load that getImage function that we just created, and it will take x and y's position, height and width. So position, let me say 53, 113, and width would be 8, height would be 14, and let me just copy all of it and just paste it out here. And basically this is getting the different type of images of our coin. So here in this case of 53, I'll say 4, and you can always check for this position, and height and width should be same as that of before, and the next point would be 20, 113, and next would be 36 and 113. So we have now set of frames, and in that frame we'll just append bunch of images. So next important thing we're gonna do is update. So this will basically update our viewport and obviously our current time, and we'll also check for the spinning here, if the state is basically spinning or not. So I'll say that is just give me the game info. So just let me see what the game info is about and viewport. So what you're gonna do here, we'll just update the coin behavior here. So first we'll say if the current time here, that is from this current time, just initialize it as game and info, and just get this current time here, that is from this c dot current time. So we have now initialized the current time. Next thing what you're gonna do is we'll just set the viewport, and the viewport should be now viewport. So after that what you're gonna do is we'll say self.state here, if this state is basically the spinning state, and that should be checked like c, that is constant dot spinning. So if it is the spinning state, we'll just call this spinning function, which will be creating in a bit moment, and we're done with this update basically. So what you're gonna do next is obviously creating this spinning function. So this will basically take care of the spinning of our coin. So let me just say spinning. So just make here spinning, and this is the action basically when the coin is in the spinning state. So let's implement the code here. So first we'll just get the image, and that should be from the frames because we have appended in the frames all the images. So I'll say self.frameIndex. So get the image according to the frame index, and get this rect y position first, and this rect y position should be increased as in velocity here, should be y velocity, because it is just spinning in the y basically, and just put that y velocity here to an effect of the gravity. So just get that gravity here, constant gravity, maybe 1.5, and we'll check the condition now, that is if the current time is basically greater than the animator timer. So that means we'll just check here self.current time minus, and self.animator timer is maybe greater than 80 millisecond. Then what you gonna do here is we'll check again from the frame index. So if the frame index, let me say self.frame index here. So if this frame index is less than 3, then just increase this frame index. That means just get this frame index first and increase with an unit value. So next thing what you're gonna do, else if it is not less than 3, just assign these again to 3. So basically this is to get this all of this image. You can see we have only here 4. That means we'll just assign, if it is less than 0, just start from here again, from the first part. So next thing what you're gonna do here is we'll just self create this animator timer to be obviously the current timer. So next thing what you're gonna check is we'll just check now for this bottom height and obviously our initial height. So that should be implemented outside of this. So this animator timer should be here. Okay, let me see. It is saying outer indentation level here. Now let's check if the bottom here is greater than the initial height. That means if this rect that we created out of this image bottom is greater than, let me say, initial height. Yes, if it is greater than initial height, what you're gonna do, obviously we'll just kill that image or object from our gameplay, and I'll say this score group. So that means the player has basically hit that or collide with that coin, and the coin has been dismissed from our gameplay. So next thing you're gonna do is just append that score now. So that should be here something that is score, but we haven't implemented the score class yet, so we won't be dealing with this score append till now, which will be the basically in this upcoming lectures, and we'll just implement that score in this score group dot append. So in the next lecture we'll make our bricks for our game, and then we'll just work with this score and obviously with this level1.py, and we'll check our game. So see you in the next.